Uh, so Kim, would you just, I'm going to ask you some numbers and would you mind giving it to me? So are you ready? Ladder on the wall, girls. And what was your angle, Kim, in your first configuration? 72 degrees. And there were two torques going this way and a torque going this way. Now, you have to be careful. This angle is not 72, but for her, 28. Right? Wait, let me see. I think, did I hit record? Hold on, let me make sure I recorded. Oh, good, yeah, good. All right, so with Kim's numbers, now, so what you have here is you're using the bottom as the pivot, and you have three torques, this torque going this way, and the other two torques go the opposite direction. So we don't know F wall, so we just write F wall. Now this angle is also 72. Sine 72 degrees times the moment arm. Could you give that to me? The whole ladder was that 0.6? Really? Okay, 0.61 meters. So that torque equals the two torques of the weight. So could you give me the top weight? We'll call it M hanging. What was the first? Was it point? I think it's point. Right. Well, not 2 because you multiply by 10. Could you do 0.2 times 9.8? Oh. Did someone give you that? 0.2 times 9.8? Everybody have that for me?
I think it was 0.31.
Oh, you think the ladder was? No, we're doing the hanging weight.
Oh yeah, 0.2.
Yeah, 0.2. We're gonna multiply by. Would you do that? Multiply by 9.8 for me? Yeah.
1.96.
Okay, so the hanging weight 1.9. Everybody will have that.
Also, where are these numbers? Like the numbers that Abel come from?
Well, that's what you determined. Remember how you kept.
From what part?
Well, that was the data you collect. Remember how you kept pulling back the ladder until it finally slid? You should have that, gather that info. Do you have that, Olivia? You're in the group? Yeah, it's looking at.
I just think the person that is absent has our data.
Okay, so the hanging weight now, so it's times sine of 28. Okay, then the moment arm was what, girls, for the hanging weight? What was the moment arm?
0.23 minutes.
Oh, no, it really can't from the pivot, from the bottom of the ladder? 0.23 meters. Because if the whole ladder is 0.61, the top weight, does anybody have the moment arm of the top mass? It should be close to 0.61, yeah. What's that? Yeah, that sounds more like it. 0.53? Yeah, that's, you see what I mean, Kim? Because it would have to be close to, yeah, thank you. All right, that's the moment arm plus the other hanging weight. This is the ladder. What was the mass of the ladder, girls? Well, the weight, you have to eat the mass. What the weight of the ladder? Does anybody have that for me? Yes?
0.31 kg.
All right, thank you. Yeah, that sounds right. I remember that, times 9.8. Where do you put, then sine of 28 again? And the moment arm was, that's like the middle of the ladder, which is what was that, girls? Is that 0.3 something? What was the moment arm? Because this is the weight, right? So can I have that half the ladder? I guess it is half the ladder, right? Could you give me half? That would be, let's say it's something like 0.3. Close to it, right? And so what are you going to be able to find F wall? When you're done, you do the math. Now here's the deal. What we do for this one is what we do for the second configuration. Now ready? What are we going to do with F wall? Ready? Now let's do sum of the forces of the x direction equals how much, Sophia? Sum of the forces in the x direction equal how much? Of course, equal. Now, why did I do that? Because ready? F wall, which we'll get, equals, well, what's the force on the bottom that goes to the left? Right down here. Do you know what that is? What's that force on the bottom? Yeah, so put a little F over there. And check it out. When I find F wall, I can find friction. And that's really good because I want the coefficient of friction. Did I lose anybody? Did I lose anybody? Yes.
What should you do to find
Great, that's the next question. So does anybody know what will we then do? Because we'll then have the friction. What do we do to find the normal force? She's thinking ahead, she's good. What are we gonna do? Now let's draw the normal force in the picture. Looks, I bet, Victoria, you can actually get it when you see it. F normal, right? Because with normal, I can get the coefficient. I think we know. You know we can do that? It's some of that old school stuff. Some of the, beautiful. So what you'll do to get, so sum of the forces in a y equals 0. So the ups equal the downs. And remember, what's that going to get you? That's going to get you F normal. You're going to get F normal from that, and then you get the coefficients. The equation. Did I lose anybody there? So what do you do on the next one? Same thing, different numbers. See if you can do it all by yourself. Did you follow that? Same deal, different numbers, and you should get it. Yeah.
Can you say what numbers
Were they similar to the? Everyone's got similar numbers. I mean, your answer? Well, you know, I would better be able to evaluate if you can find duty coefficients. Hey girls, one more thing before I stop. Should I get a number that is less than 1 or greater than 1 for this coefficient? Less than 1, no units, right? So you want to do, so what you do is, friction is mu times, you all know this, mu times normal. I have a friction out of the normal, so I just get the, okay. Is that clear? And you do it the second time, and I want to make your life a little easier. Ready? We get a little easier. Turn to the last page, and you can cross out 2. So there's hardly anything to do the weekend. Last page, cross out 2. Alrighty, so there you go, not much to do. This is not tonight's homework, it's Friday's homework. Let me stop this. Before I exit out, anybody want me to just run through anything? So we're doing the torque equation to get F wall. F wall gives us friction. By the way, when did you get these coefficients? Work on it. Yeah, she said, look at my numbers. I could, yeah. Yeah, well, because the left's equal to right. You all good? Yeah, because there's only one left wall and one right, you see? The right equals the left. So that friction, once we get F wall, we get friction in the bottom. Pretty neat, right? You do it second time because I guess you get a slightly different number, you have a slightly different position and molar, so it's not going to be follow the pattern. Let's stop this and I'll post this. If you want to see this again, girls, I will post it.